Imagine you have a piece of land, this shape, kind of like a rectangle with one piece cut out, and you needed to calculate the area of this land. Well, you could divide this up into 3 rectangles, calculate those 3, the area of those, and then add them up. Or, alternatively, you could make the whole thing into a regular shape and then subtract this from the total area. And depending on how the measurements go, the first method might be easier, or the second method. And what I like about maths is that it's all about helping you find the easiest way to solve a problem. I quite like the second method because it's an example of thinking outside of the box. And I think it's a more elegant way of looking at the problem. So let's just imagine that the measurements work out kind of like this. So this is 2 here, and this is 1, and this is 2 here, adding up to 3, and this is 3 here, adding up to 5. So let's try that second method. We're going to take the total area, which is 5 times 3 equals 15. And then the area of the little rectangle, which is 1 times 2 equals 2. And then we'll just subtract 2 from 15, and that gives us 13. 13 is the area of that irregular shape. I like that method. It works really well. Now let's imagine we were given a slightly trickier problem. So we're going to try a different shape here. It's also an irregular shape, but instead of being able to measure things directly, we're going to introduce some variables. So this one here is going to be 2a, where that's a variable. We don't know what the value of that is, but we know that this is 2 times that value. And I'm going to put another formula on the top here as well. And this one is going to be 3a. It's a little bit more complicated. 3a plus 4. Okay, now you might ask, well, how did this happen? Well, this could happen in a number of ways, but in this particular example is just, you could think about it as a practice of working out how to manipulate things when you don't really know the details. So we know that there's a number in there, and that number there, a, is the same as that number there, a, but we don't know exactly what the value of that is. And in real physical terms, we might find it difficult to imagine a situation like this, but it does happen quite often. And this type of operation here, working out the numbers, works just as well if we know what the value of those numbers is, as if we don't know the value of those numbers. We can still move things around, we can arrange things, and we can possibly make the problem easier to solve. So let's do that. Now you may notice our shape is a little bit wonky here in terms of the length of this 4 here is a bit short compared to the length of that 6. It doesn't really matter because it's the overall shape that's going to help us. Okay, so applying this first idea over here, what I'm going to do is I'm going to complete this to make it a regular shape. So now I know that the overall area is going to be 6 times whatever that is. Okay, so I'm going to write that down. 6 times whatever that is. Okay, so the area equals 6 times, and let's put that in brackets here so that we don't muck it up, 3a plus 4. Okay, that's the overall area. Okay, and the area of this bit here is going to be, let's see now, we need to calculate what this bit here is, and we need to calculate what this bit here is. Okay, so this bit here is easy because it's going to be 6 minus 4. So this is going to be 2, okay? And this bit here is going to be that expression minus this, okay? So that's going to be 3a plus 4 minus 2a. Okay, let's put that all in brackets there. Okay, and so the area of this will be 2 times that. Okay, so this is going to be the area of the big box, and this is going to be the area of the small box. Okay, so this is going to be 2 times all of this, right? So that's going to be 3a plus 4 minus 2a. And you can see there's a lot of simplifications that I can make already. And the area that we want is going to be this area minus this area. So I'm going to write all that out. Okay, so I'm going to write 6 times 3a plus 4, 3a plus 4, and then I'm going to minus 2 times 3a plus 4 minus 2a. Okay, now what I need to do is simplify that. And in some mathematical problems, you start with a diagram like this so that you can make some kind of sense of it. And in other mathematical problems, you know, you'll just get an expression like this and your job is to simplify it. But let's see how this simplifies now. To simplify this, we're going to use a technique which refers to collecting like terms. And like here just means similar. And you may notice that there's an A here and an A there. When we were looking at this expression here, you could probably already see that this 3a minus this 2a could be simplified to just 1a. But I've kept all of the terms here so that you can see that at its most expanded, you've got a fairly complicated expression. But don't be afraid of that, because we can simplify it later. The important thing is not to forget any of the terms, so that's why it's a good idea to write it all out. This also allows you to go backwards and work out if you've made any mistakes. So we're going to collect like terms, and our like terms are the a's here, here, and here. And in a way, the other terms that don't have a, they're also like. Okay, so what we're going to do is multiply all these things out. And when we see brackets like that, so 6 times all of that in the brackets, it's going to be 6 times this term plus 6 times that term. And then there's a minus here. And then there's a 2 times this term, 2 times that 4, 2 times that minus 2a. But all of that is minus. So we need to keep track of our minuses as well. Okay, so let's do this term. That's going to be relatively easy. So that'll be 6 times 3 times a plus 6 times 4. So let's bring that down. So that 6 times 3, 18a plus 6 times 4, 24. Okay, so that's that bit. Now, with this minus sign here, it's a good idea to keep that minus sign by itself until you get used to doing this kind of operation, because it's easy to muck this up. So what I'm going to do is put this minus sign here, and I'm just going to take care of all of this first. Okay, put that all in brackets so that I don't make a mistake. Okay, so this 2 times 3a is, let's do it a bit quicker here, so that's 6a, and then 2 times 4 plus 2 times 4 is 8, and this 2 times minus 2a, so that'll be minus 4a. Okay, now what I've done here artificially, if you like, just to help me keep it straight in my head, is I've put brackets around there as a way of temporarily remembering to do that minus sign last. Okay, once you get used to this sort of thing, you'll be able to do it more rapidly. But now you can see what's going to happen. This is 18a plus 24. We potentially can simplify this a bit more, but let's just leave that like it is. And so now this is going to be, this minus sign is like a -1 times each of these terms. So this becomes a minus 6a, this becomes a minus 8, and this becomes a plus 4a. So you can see why it was a good idea to use those brackets there, just to help us simplify the steps. And if we simplify the steps, we're less likely to make a mistake. Okay, so now what we want to do is collect like terms. Let's bring all of these a's together. So we've got an 18a here, we've got a minus 6a there, we've got a plus 4a there. Okay, and then we've got a plus 24 here, and we've got a minus 8 there. Okay, and so what we've done here now is collected all of our a's together. And there's a couple of ways we could do this. We could just say, okay, well, this is 18 minus 6 plus 4. So that's 12 plus 4 is 16a. You could just do that 16a, like so. Okay, let's just check that again. 18 minus 6 is 12, plus 4 is 16. Yep, okay. And then 24 minus 8, that's 16, like that. So now our final expression is 16a plus 16. If we wanted to go a bit further, we could just say this is, we could just take the 16 here outside of a bracket and express it this way. 16a plus 16 is the same as 16a plus 16 outside of a plus 1. Now for some purposes that expression might be simpler, that might be okay, and for other purposes this expression might be the simplest way to finish up. And that then represents the area that we were looking for. And if we ever found out what a actually is, we can simply just calculate what the answer is. So it looked really messy there for a while, but we finally got to a simple expression that gives us what we want.